Standard test is the difference between two means. So when we're testing, we divide a population into two groups based on a categorical variable and compare the means. So in our previous example, we had a population of students. We divided it into two groups, males and females. The variable was sex. And we compared the means of the two subgroups. The null hypothesis is that the means are equal. Now it's important to understand the difference between population samples. Our hypothesis is that the mean of the full population are equal. But we don't have the full populations, we only have the samples. So long as parametric assumptions are met, which we described in the previous slide, we can use the t-distribution and calculate a t-score, which we've used before. Now, here's the t calculation. Now, if I just put on my pointer, you can see here, straightforward, x1 is the mean of the first population, x2 is the mean of the second sample, sorry, those are sample means, and mu1 is the mean of the full population, mu2 is the mean of the full second population. Now our hypothesis is that the two population means are equal, so that means mu1 and mu2 must be the same, so that always resolves as 0. Underneath the line we have square root of the standard deviation for the first sample over the count of the first sample, or the number of items, plus the standard deviation of the second sample over the count of items. Now that standard deviation in the second sample is minus, but squared, so it always comes out as a positive number. Now the important thing to remember is that above the line we only have x1 minus x2. So we're basically saying, is there a difference between mu1 and mu2? But what we have is the difference between x1 and x2. So if those two are identical, that means the number above the line is 0. That means t is 0. So t, well, for when the population and means and sample means are identical, t is going to be 0. So, and as t gets larger, we're more likely, as these two numbers, as the difference between x1 and x2 get larger, t is going to get larger, and we're more likely to be in the reject zone of the null hypothesis.